in this session we're going to build this application, and what it does is that it predicts delay in airspace travel. So for instance, if you are embarking on a journey on an airline and then you came across some inconsistencies, there will be a predicted like arrival delay. So what this does is that the AI predicts the arrival delay in this situation based on inconsistencies. Like for instance, here from Dublin to Boston, it had predicted 64 minutes. I will be focusing squarely on the Atlantics. Yeah, yeah, playing around the Atlantics right here is what we'll be focusing on. So let's get started with developing this application. Yeah, and we'll be focusing on using Claude code in this situation. Let's get started. First of all, you create your project folder. I've created my folder and I've named it Airspace V2, and I've also got my prompting in place right now. And then it depends, if you like to follow my prompting, it's fine. And then if you wouldn't like to follow my prompting, if you like to get there right now, here I'm on Claude, and let's get started. So I'll start with a project brief. This project brief is what will be used as the Claude.markdown file. And let's get started. We'll ask it to set up the project memory. Yes, set up the project memory before any code. Let's play memory properly. Memory before any code. Create a Claude.md for a portfolio web app called Airspace. It tracks live aircrafts on a map and layers ML on top to predict arrival delays and flag anomalous flights. It runs on public data and is not an operational air traffic system. Write these decisions into Claude.md. Yeah, so in the Claude.md, you have to specify your stack and then things like that. Stack Next.js, a router, TypeScript, Tailwind, MapLibre GL for the map, CARTO basemap, no API key, data from OpenSky. We'll be making use of external data. Forward to clients credentials, local storage via Node.js, built-in Node SQLite at data slash airspace.db here for a local databases. Since we are building a project, we are running everything here locally. db.ts ml served from API routes call rules. The OpenSky Polar is shared and self-rate limiting. A module level cache refreshes at most once per 10 seconds, no matter how many clients ask, catches the whole token and uses a North Atlantic Europe bounding box. The browser never calls OpenSky directly. It's post/API/aircraft every 5 seconds. Phases commits after each. Mock UI first, then OpenSky to log each poll to SQLite. 3. Delay model. 4. Anomaly detection. 5. Deploy. 6. Write up. Then the next step, conventions, small reviewable changes, mock data first, diagnose from real error before rewriting. Keep this file updated. Only create Claude.md, do not scaffold the app yet. I think that's it. Yeah, for Claude.md to be created. That's it. Now it should create a Claude.markdown file. It depends on what Anthropic model you're using. You could use the Sonnet 4.6. However, I'm using the Opus 4.8 for this project right now, and let it scaffold. Once it's done, we'll move on to the next level. And now great job has been done already. Created the Claude markdown file. It has also added specific rules for us, and then also done memory as well. So the next step of development is we'll add in the first prompt. Like this prompt is in layers. We can give Claude Code the entire prompt all at once. We need to be giving it in layers step by step. So the first one is to scaffold and also the map itself. Let me give it the next prompt. Scaffold a Next.js app router TypeScript Tailwind and install MapLibre GL. So we are working with maps, so that's it. A full screen MapLibre map as the hero of the page. CARTO Voyager style. So that is the style we are going to use for the mapping system. Like it's been used to render map online. Now let me give it the link. Basemaps CARTO cdn.com /gl /wager gl style.json centered on the North Atlantic, about longitude -30, latitude 50, zooming of 3.2. The map owns up pan and zoom and fills the viewport. Custom zoom controls the plus minus resets floating bottom left wired to the map. The map is the client's component. Browser only. Dynamic imports with SSR disabled. Verify, run it, and confirm the base map and city labels. Render full screen with no console errors. Commit scaffold Next.js app on full screen map like base map. So giving it this prompt now, and then let's see the results. Now it's asking for permissions. So in this situation, you can give Claude the plan mode if you want Claude to improve on the plan auto mode, bypass permission. We are currently on accept edits. Yes, so it's accepting edits. You can also give it as permissions. And development is to give it a second prompt. So let's look at the result of this first prompt here. We're on the local host 3001. Yes, so it has brought up the map for us automatically. Map of Africa, America, South America, scenes and the like. So let me input in the second layer of prompts. Yeah, and that will be build the entire interface unseated mock data before any real API. Dark lib flight.cs plus lib slash geo.cs. I'm done. Great circle helpers bearing points along routes distance in lib slash geo.cs a deterministic generator for about 50 flights over the North Atlantic. Each flight has a call sign, airline, aircraft type, origin and destination, airports, a great circle routes, position, altitude, ground speed, heading, vertical speed, status, nominal, delayed, anomaly, and the placeholder, delay, prediction, mean, standard deviation, confidence, animate flight so they glide along their routes each frame. Render aircraft on a transparent 2D canvas, overlay on top of MapLibre, projected with map.project, each frame not as MapLibre layers. Small rotated plane markers colored by status, cyan nominal, amber delayed, red flagged, flagged markers pause, selected aircraft, a ring, a label tag, call sign, origin, destination, a map click, select a plane, a mouse move set over. So here are the set of rules. Yeah, the prompting that I have to give into Claude. So we'll move on to the next step of development. And then Chrome, dark glass panels floating over the lights map. Top bar, airspace, word mark, and a prototype peel, a search box, call sign, or airport, and the live indicator with a pulsing dot, latency in milliseconds, and a UTC clock. Left rail, starts tracked white, delayed amber, flagged red, flame numbers, all delayed, flag tabs, and alert list with severity dots and naturally varied row height, and the footer line public ADS B demo data, not operational, writes detail panel, and select call sign, airline, and type a status peel, a route row with origin and destination code plus X kilometer, Y percent, X kilometer, Y percent, and route a 2 by 3 monospace start grid, altitude, ground speed, heading, vertical speed, latitude, longitude, and predicted arrival delay block with a large number, a confidence value, and a horizontal range with a shaded confidence band. And then the style, dark navy base, cyan accent, amber and red used only for meaning. Sans serif text, monospace for all numbers. Verify, run it, selecting a plane opens the panel with its data. The filter tabs work. Markers glide and rotate. Commit full UI on mock data. Markers left rails detail panel. So here's the entire prompting for the second round of development. If we look through the first stage of development here and I look through the prompting, it will give us the total amount of time it took to develop everything. So let's have a quick look. Yeah, this was like around 30 minutes ago. Yeah, before I started the second. So let's go with the second prompting and let's view our results. Yeah, and it's also asking, do we trust the workspace? Yeah, Claude is also asking that question. Yeah, that's great. We trust the workspace. Finally, and now it has run through the second phase of development. So let's have a look at the progress. Now you can see here amazing progress, fantastic progress. Yeah, it's talking about Air Canada here from Zurich to Washington. The altitude, the ground speed, vertical speed, and things like that. And you can see everything here is mock data, so it's not like real data. And you can also see here the one here at risk. Yeah, yeah, heading towards Washington. Yeah, it's Lufthansa airline has been flagged. Yeah, from Washington to Montreal, 72 minutes, the altitude, the speed, and so many informations. And then also at the left side here to list the aircraft or the air travel, 50 tracked, 9 delayed, 2 flagged. So that is how everything is right now. So the next stage of development is to now add real data, and in this case we'll be making use of OpenSky API. So let's have a look at OpenSky. Yeah, OpenSky API. Yeah. So all you need to do is register. If you haven't registered yet, register, create an account, sign in, like the way I'm about to sign in right now, and then get your API client and your credentials. That's it, and then you paste it into Visual Studio Code or any form of code editor which you are using. Yeah, so to get Visual Studio Code, you can go online and download Visual Studio Code. Visual Studio Code. So it is the most popular code editor you can use so that you are able to add your environment variable information. And as you are using Claude Code, yeah, it will guide you on how to add the environment variable information so you don't leak those environment variable information to Claude Code, or you don't leak it to any form of AI agent, and it will be safe. So let's move on to the third stage of development, the third prompts. Yeah, and then now replace mock aircraft positions with real OpenSky data behind a shared cache. I will add OpenSky client's ID and OpenSky client secrets to .env the local server as lib slash OpenSky .cs server only OAuth clients credentials token cached and refreshed early get aircraft fetch states slash all over a North Atlantic Europe bounding box normalize each state vector to ICAO 24 call sign longitude latitude alt foot speed kilometers HGFSFPM with units conversions drop null positions and on ground aircraft and cap the count. Refresh at most once per 10 seconds. Dedupe concurrent refreshes and serve the last good data on failure. Last route get slash API slash aircraft returns time count source aircraft no caching client library slash live.ts pool slash API slash aircraft every 5 seconds and merge live aircraft into existing flight shape, real positions, altitude, and speed, heading, and vertical speed from OpenSky. Status, routes, and delay prediction stay at deterministic mock values keyed by ICAO 24. So right now, the delay predictions which we add here, which will be done by the AI models, the LLM models, and also the anomalous model, yeah, will be done later on. But now it will be mock, so it will be like a mock value here right now till we move on to the next stage of development. Dead recon positions between poles for a smooth glide, then snap to the authoritative position on each pole for a smooth on each post, yeah. Show the data source in the top bar, live versus mock slash offline, and fall back to the mock scene if the feed is empty. Verify call slash API slash aircraft and confirm a code call. Return source live with real aircraft and call within 10 seconds. Return source cache. Confirm the map fills with real traffic and the commits live OpenSky feed behind a shared 10-second hash. And in the committee right here, Claude Code is also taking and to commit each stage of development to Git. So there is a version control in order to move back to the previous version. So now is running this task. So let's wait for it to run and then we'll move on to the next stage of development. It's completed the third stage. Super amazing result. Is now fetching real life data. So let's have a quick look. Now it's fetching real life data. So this is real life data, not just mocked data. British Airways from Lisbon to Copenhagen. See KLM, yeah, and British Airways here from Manchester to Madrid. So let's move on to the fourth step. And this fourth step is where we are saving data to a local database. And our main aim is that we need data to be able to run our anomaly model for it to be able to detect anomaly, because right now the anomaly is just guessing here, but it doesn't have to guess. So there should be a model that will do the job. So let's move to the fourth step. Add a local data store using Node.js built-in node SQLite. No external service, no extra dependencies. first confirm node SQLite loads on the installed node version. Library, the database TypeScript file. So this is server only. Open data slash airspace.database in while mode. Create a pool table and an aircraft OBS table. That we have TS ICL 24 longitude, latitude, altitude, speed, VSFPM, width indices, provide log pool that writes a snapshot in a transaction, set throttles to at most once per 60 seconds and never choose. Call log pull from API slash the aircraft only on freshly fetch data, add get API start, returning row count. Now, yeah, we've been adding a lot of secrets like the API secret keys that are not meant to be showed in the public. We need git ignore the data directory. So it's not only API secrets that will need to be git ignored, also the data directory as well, and verification. Verify it slash API aircraft a few times, then the API starts and confirm observations and distinct are growing. Then the commit message log each live poll to local SQLite. Yeah, so here is the entire prompt, the fourth section of prompting. So you see, I'm not giving Claude code an entire prompt alone. So he's giving sections and sections of prompting into Claude code. So this is the first step. Let's see how it goes before we move on to the final one. And now this is amazing due to the fact that it has already built the local database for us. And the next step of development is not actually this delay model. So we're going to work on the real anomaly detection model first of all. So let's give it the prompt. Yeah, and this is going to give us and unsupervised anomaly detection. That's just going to build for us. Add unsupervised anomaly detection on the trajectory. So you could even use push and hold to record. Yes, let me try to see if the recording would work. Add unsupervised anomaly detection on the trajectory data we are logging. No labels needed. ML slash Python scikit-learn features.py per aircraft trajectory features from aircraft OBS, altitude jitter, ground speed and vertical rate deviation, heading change plus latest altitude speed vertical rate, train underscore anomaly.py, fits isolation forest, contamination 0.03, save to data slash model slash anomaly dot joblib, write an anomaly score table, ICAO 24 score, and then is underscore anomaly, and print the flag rates, score percentiles, and the top flag trajectories. Refuse to train below about 30 aircrafts. Score underscore anomaly.py, load the model and refresh anomaly underscore score for recently seen aircraft. Serve it library slash db.cs. You add the anomaly underscore score table plus getting of the anomaly score reader, and then the library slash ml.ts. It triggers the Python scorer in the background. Throttled fire and forget slash API slash aircraft. Attach the real anomaly flag and score to each aircraft. Lib slash live.ts. So you add the anomaly score, getting of ml.ts. So slash ml dot ts, trigger the Python scorer in the background. Throttled fire and forget slash API slash aircraft, attaches the real anomaly flag and score to each aircraft, and lib slash live.ts, use the real flag to drive the flag status and a critical alert that shows the score. The delay value stays mock. Add npm script train and score. So the npm script for training and scoring, and gather data for a while first so there are enough aircraft to train. Then run npm run train. Verify that confirm flagged aircrafts appear in the UI with the real score in their alert and the flag rate is near 3%, and commit double colon anomaly detection isolation forest wired into flagged. So this is the entire console. So this is the entire prompting now, and this is the fact that I'm working with Opus 4.8 is even able to even figure out a lot of things in this prompt. And also I didn't type it at all. I made use of the audio session. I just held it and record, and I added my prompts into it, so it will be able to make high sense of it because of it is a high performing LLM model. So let's click on it. And so this is the section 5. And what does is that it's what build the unsupervised anomaly detection, like to detect any form of anomaly in the aircraft routine, whether it's traveling to from maybe New York to London. If there are some anomaly, to detect it. And then later on we'll also make use of LLM to build a system where the LLM is predicting the lateness time. It will predict the lateness time in minutes or in hours. Yeah, this is amazing. Yeah, it has built the anomalous model for us. So this one will help detect anomalies. So the next stage of development is the delay, estimated delay, like to have like an estimated delay. However, we could add like a model, like we could build like a delay model, but instead we could just make use of Claude instead to help in the delay model. So Claude will create like an estimated delay on it. So let me type in that prompt. So you could also improve on your prompt using Claude AI. If you go to Claude AI, you ask it that let me to write like a well refined prompt to like build like a on select delay estimates using Claude API. So it will be able to build the delay estimate. However, if you want to like follow my prompting, you can just follow along, and then let me record the prompt. Yeah, so let's hold it. Build a reason estimate from Claude for the selected flight only. I will add Anthropic API key to the env.local. Install Anthropic AI slash SDK, and the route will be the app slash API slash predicts, and that will be server only. Posts one flight, live telemetry and routes. Call Claude Opus 4.7 with a structured output JSON schema, and return delay, minute, confidence, and reasoning. This system prompts should ask it to reason from flight phase, in fact from altitude, vertical speed, percent, and route, ground speed versus a typical jet cruise, route length, and a time of day, and to keep the reasoning to one sentence. If Anthropic API key is missing, return error unconfigured. So the UI fall back to the mock. Clients, when a flight is selected, call slash API slash predict once and catch the result by ICAO24. Do not call per poll. In the detail panel, replace the mock delay block with the estimate, the number, confidence, a range bar derived from confidence, the reasoning sentence, and a clear LLM estimate tag. Show estimating with Claude while loading and fall back to the mock on error. Make the panel footer honest. This is a reason estimate from live telemetry, not a trained or operational prediction. Verify. Clicking a flight shows a real Claude estimate with a reasoning sentence, and removing the key fallbacks to the mock. Commit. On select Claude delay estimate slash API predicts Opus 4.7. Yeah, you can see here now it has taken the prompting here, and here you can see I asked it to install the Anthropic SDK. I told it that I'll add Anthropic API key, and then it should return the results in a JSON schema. This one is schema. Yes, schema. return delay, minutes, confidence, and reasoning. And once there's error, it should fall back to the mock. And then for adding the API keys, like I said, you install Visual Studio Code, and then once you've installed Visual Studio Code, Claude will write this scikit-learn, and you create your environment variable. And in the environment variable, you add in your keys, API keys that we've been using, the OpenSky API key, Anthropic API key. So let's click in this, and then let's wait for our results. You can see that this prompting is well detailed. So if you use Claude itself to write well detailed prompts, it's better than you just writing prompts yourself. Super amazing. Even the fact that Claude has not even finished running everything, is about to restart the development server. Let's have a look at how it's working now. You can see here this prediction here, Lufthansa airline from Lisbon to Dublin, 33 kilometers, 98% route, the altitude, and then the arrival delay -1 minute. This shows that it's going to get earlier to its destination. However, if you look into these ones here that are amber, or it has reloaded, see, Claude has just restarted the server, so it's about to restart the server. So let's wait for the server to be restarted, and then we'll get our results. Currently on localhost 3001. Okay. Yes. Yeah. Mm. It's starting. Okay. Okay. Let's check it again. Yeah, finally restarted. Yeah, so the ones with amber color, they are the ones that are they are they have an estimated delay. However, it is no highly crucial or very serious. Look at this here. American airline from Miami to London, 8 minutes. Yeah, and the reason for this is mild headwinds. Yeah, and let's look for something critical here in this situation. You can see here, this is critical. Yeah, and then now it's estimating with Claude 45 minutes. Telemetry is inconsistent. Yeah, and this is from Toronto to Lisbon. So that's everything about this tutorial here. And then if you like to deploy this application to, let's say, online, you can just deploy on Vercel. Yeah, by telling Claude that, how about, yeah, how can you deploy this application on Vercel, and it deploy automatically for you. And then, however, I'm not deploying now, but if you like to deploy this project, you can deploy. So that's the finality of this project.